Hello, everyone. So, our lesson for today will now start with a new chapter. So, this is actually chapter 5 that talks about rational and radical expressions. So, this is section 5.1, which is about nth root and an introduction to rational exponents. Okay. So, how do we define the nth root? Okay. Generally, when you learn square roots and cube roots, okay, we know that the square root of 16 is what? 4, because 4 squared equals what? 16, right? Also, you know that the cube root of 8 equals what? 2, because 2 to the third equals 8, okay? Which means in this case, if that's going to be the case, 2 is the cube root of 8, 4 is the square root of 16. So in general, for any integer n equal greater than 1, okay, if b raised to the n equals a, then you can see that b is the nth root of a. Okay, so look into this equation. Okay. Also, a review of the exponents tells you that you can convert a square root sign to an exponential form. That is, the nth root of a is simply equal to a raised to the 1 over n. Okay, so take note of this definitions. Okay, how do we get the real roots of a? Okay, so this is from your textbook. Okay, so let n would now be a number greater than integer to be greater than 1, and let a be a real number. Okay, so if n is an even integer, okay, that is the index, okay, of the roots. The index, the numbers that you see that there. See that? If that's even, that is, if it's 2, 4, 6, then, and if the ones inside is a negative, then there's no real roots. Okay, so if x equal to 0, if a equal to 0, then the answer is 0. And then if a is positive, you get 2 real roots. However, when n is odd, if n is odd and then a is negative, then you have 1 real root. Okay, and then when a equal to 0, there is also answer equal to 0. And then when a is positive, therefore there's also 1 nth root. Usually when a is negative, the real root becomes negative in most cases. If it's positive, the real root becomes positive. Okay, how do we know about that? Okay, find indicated real roots or real roots. Okay, or sim of a, or simply you just have to find the nth root of a. Okay, so here n is 3 and then a is 216. As you can see, n here is odd and then a is negative. So the cube root of negative 216, which means if it's odd and and a negative, there's a 1 real root. So we all know that when you get the cube root of negative 216, and that gives you negative 6, because it's negative 6 times negative 6 times negative 6 equals negative 216. Okay? How about this one? N equals 4 and a equals 81. So n is even, a is positive, which means you're going to get 2 real roots. Okay, so 2 real fourth roots. So you have the fourth root of 81 gives you plus and minus 3. Okay, so definition, what are rational exponents? So let a raised to the 1 over n be an nth root of a, and let m be a positive integer. So this means that the exponent doesn't have to be just 1 over n. It could be a fraction. Okay, so the equivalent of a raised to the m over n is just simply the nth root of a raised to the m. And again, the rule of exponent, if it's negative, you just simply have to bring it down. Okay? But there's an easy way when we're going to use this when we solve equations or expressions, okay, that it contains rational exponents. Okay, so let's start working on sum. So evaluate each expression and then we simplify. So you have 16 raised to the 3 halves. How do we do that? Now, we all know that 16 is 4 times 4, right? Or 4 squared. So I can change 16 as 4 squared. It's still going to be raised to what? 3 over 2. So it's an exponent raised to an exponent, So which means the 2 here and the 2 down here on the fraction cancels out, leaving you with 3. Or you just simply multiply. 2 times 3 is 6. 6 divided by 2 is 3. So you get 4 raised to the third. Answer is what? 64. Okay? How about this one? 32 raised to the negative 3 over 5. Now, the easiest way is to express 32 that has an exponent of 5. Here I use 16 as 4 squared because I need to cancel the 2 here and the 2 there. Okay? So 32 can be expressed as 2 raised to the 5th. Right? So 32 is 2 to the 5th. Notice the 5 here and the 5 down there cancels out. Okay? That leaves me with negative 3. Right? So by definition, 2 to the negative 3, make it positive, bring it down. And 2 to the third is 1 over 8. Okay? Next example. 81 raised to the 3/4. Okay? Now we know that 81 is 9 times 9, right? But since this is 4, I have to express it as 3 times 3 times 3 times 3. So 4 times 3 to the 4th. Okay? So 81 can be expressed as 3 to the 4th. It can also be 9 squared if you want. Okay? But if it's 9 squared, okay, that's 9. You're still going to end up with a fraction. Okay? Because 2 times 3 is 6. 6 divided by 4 is 3 over 2. That's why it has to be a 4. So which means 4 times 3 is 12. 12 divided by 4 is 3. So you get now here 3 raised to the third is 27. Okay? Sometimes you got to use calculators. Okay? Though the previous ones, you can use calculators in this too. You can type them in the calculator if you want. Okay? But it's still going to come up as an exact answer. But some cases, you have to use a scientific calculator. Okay? So if I'm going to do that, okay, let's see how this one works. Okay? So if that's going to be the case, let's see how it's going to work. So 9 raised to the 1 over 5. When you use a calculator, it's going to be 1.55. You're going to check it with you. Okay? So just simply type it in. 12 raised to the 3/8. Express it as 2.54. And this one, you just have to change it to, okay? You have to change it to an exponent, an exponential expression, okay? That gives you that, okay? So how do you solve equations? So say, for example, find the real solutions of 4x to the 5th equals 128. So the easiest way is first copy the original equation, divide both equations by 4. So cancel the 4, it becomes x to the 5th, okay? And then 128 divided by 4 is 32, okay? Then take fifth root of both sides. So get the fifth root and then the fifth root. Remember, the fifth root of x to the 5th is x, and then the fifth root of 32, as what we did, is equal to 2. Okay? Let's have another example. Okay, you have now here x minus 3, quantity raised to the 4th equals 21. So let's copy the original equation. Now we need to get rid of the 4, an exponent. So I need to get the fourth root for both sides. Remember, if you get the fourth root of something that's raised to the 4th, the ones that is left is the ones inside the parentheses. Okay? So the ones on the left side, it's going to be x minus 3. While the fourth root of 21, just simply make an approximation, use your calculator. It's going to be plus and minus 2.14. Remember, it's odd and it's positive. Okay? And then add 3 to both sides. So you have now 3 plus and minus 2.14. So you have now two answers. One with a plus and one with a minus. Okay? Now, let's have a real application for this. Okay? Okay, what we have now here is a what? Ultrasound machine. Okay, so let's read. A hospital purchases an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. The hospital uses the declining balances method for depreciation So the annual depreciation rate, R, in decimal form is given by the following formula. Okay, R equals 1 minus the quantity S over C raised to the 1 over N. So in the formula, N is the useful life of the item in years. Okay, S is the salvage value in dollars, and C is the original cost. Question is, what's the annual depreciation rate did the hospital use? Okay, let's look at the formula. So here N is the useful life. So the useful life of the ultrasound machine is about 10 years. So N is 10. Salvage value, it would be the value of the ultrasound machine after 10 years, which is about 8,000. And C is the original cost, which is $50,000. So basically, those are your values. Okay? So all you got to do is just simply plug these three values to the formula up there. Okay? So I'm writing it down again. Plug the numbers, simplify, okay? And then you use a calculator. So R equals approximately equal to 0.167. So approximately, the annual depreciation rate that the hospital was using is about 16.7%. So it's going to be decreasing 16.7% every year for 10 years. Okay? So our online classwork for this. So you're going to do 20 problems. Again, each problem has many attempts. You're going to do it on big ideas. Okay. Take note of the big LIUSD and then single sign on. And the date for the deadline for this is on Wednesday. Remember, April 29, 2020 at midnight. Okay. Thank you.